All right, looks like we are live. Thanks for joining and welcome everybody to Synergetics stream number 11 on September 11th, 2021. Today in Synergetics stream number 11, the spirit for today is remember, reduce, and reuse. We'll go as usual through some key memes and themes, talk about some things to integrate in the upcoming discussions, and then we'll jump into the texts. Today in number 11, we're going to be in section 986 of Synergetics, and in subsection 90, the search for nature's coordinate system, and section 100, sequence of considerations. So this is going to be a contiguous section and a somewhat longish one. We'll see how long it takes, but it's a super interesting section, and there's a lot of very basic and also important concepts that are addressed. So we will be jumping right in. Let me just make sure everything is working with the stream here. And I'm watching on the YouTube. If anybody leaves a live chat, hopefully we can address that during the stream. Okay, on we go. Let's just review some key memes and themes before jumping into the text itself. Synergetics is relational and multi-scale thinking, both Bucky's Synergetics as well as Hakan's Synergetics. Synergetics is connected to our accessible experiences and operations, and that's something we're going to talk about in the sections today. Synergetics has no infinitesimals, infinitely large or infinitely small, and points, lines, and planes don't exist in the same way that people might have learned elsewhere. In Synergetics, we're framing design as an anticipatory cybernetic science. So design is thinking ahead of time. When you think to design something so that you can use it later, that's anticipatory design science or cybernetics. There's this relationship between tensegrity and synergetics that's somewhat like the relationship between engineering and physics. Whereas tensegrity is manifested more in physical artifacts, synergetics is more generalized, more conceptual, and it's a little bit different. One of the biggest ideas in synergetics that we're going to be talking a ton about today is this idea that space has a shape. And this sort of pattern or shape that space has is a pretty good choice if we want to pick a coordinate system for our mathematics, which is exactly where we're going to be heading later. Universe is the total scenario. Universe is the big picture, and because there's only one of it, by definition, we don't need to even qualify it by saying the universe. So if somebody ever says the universe, you know that they're not aware of synergetics that much. But whenever we're talking about a system, we're talking about minute particulars, as Blake would say. We're talking about a specific subsystem. And then also, thankfully today, we're going to be talking about 4D. And 4D has a ton of meanings in different namespaces, just like Kirby always says. There's the polytope Coxeter geometry extended Euclideanism, which is a geometrical interpretation. So just like you can have geometry in 2 dimensions, 3 dimensions, 4 dimensions, etc., that's one sense of 4D. There's also this dimensional sense in time and space, like relativity, Einstein, and Minkowski spaces, which again, we'll talk about soon. And then there's the sense of the tetrahedra and the fourness of the tetrahedra. It has 4 vertexes, 4 vertices, and also it has 4 faces. That's why it's called a tetrahedron, or it could be called a tetravertexion. We're going to talk about all these things. These are some of the really key memes of synergetics, and we're going to be talking about them in the readings soon. Not much has changed on the things to integrate. 4D time lock, I think we can remove, well, we can't remove it yet, but it will, there's 2 of them, a little bit of a 5D time lock there, but 4D time lock, we're going to be talking about that soon. So this was a fun one to make, and it's also a very important day. Some of the really fundamentals of our world and synergetics are going to be addressed in this discussion. And as always, this is just sort of one human's perspective on it at one moment. It's really an ongoing discussion and a trajectory that we're all on a sense-making journey together. So let's just go right into section 986.090, the search for nature's coordinate system. So for these sections, I will read the section just because the length and framing is pretty much just so. It's just how Bucky would have wanted it to be. And then we can see if there's any pieces that jump out. So here in section 91, we're in the search for nature's coordinate system. Bucky writes, several things were certain. Nature is capable of both omnidirectional, disorderly, dispersive, and destructive expansion, and omnidirectional, collective, selective sorting, and constructive contraction. And rays of candlelight are not parallel to one another. I decided to initiate my search for nature's coordinate system by assuming that the coordinate system must be convergently and divergently interaccommodative. That the seasons of my New England childhood brought forth spectacular transformations in nature's total interpatterning, that the transformations were not simultaneous, nor everywhere the same, that there were shaded and sun-shined upon area variables, and that they were all embraced by a comprehensive coordination altogether made me dream of comprehending the comprehensively accommodating coordinate system that had no separate departments of chemistry, physics, biology, mathematics, art, history, or languages. I said, nature has only one department and only one language. Bucky here is really setting the stage for this whole discussion that's about to continue, which is why search for a coordinate system? And there's a lot of answers to it, and there's a lot of words that might be sort of Buckyisms here, like interaccommodative. But just like we can think about convergent and divergent thinking as being part of one underlying thinking process, or we can talk about a convex and a concave surface just as being kind of two sides of the same coin, a bent coin, we want to have systems that take a paradox at one level and transcend it and put it into some sort of an integrative framework at a higher level. In other words, it's interaccommodating. And another thread that's going to be woven into these next few sections is that his personal experience, his New England childhood, is going to be woven together with some general patterns that are going to be maybe even speculated to be universal. And it's something that we're going to see again and again, the minute particulars with the generalizations. So specific and general, the species and the genius, both happening together, because that's kind of how things are. Like when a ball falls off a building, it's the specifics of that exact ball, but also there's some generalizations, like some equations that might reflect the dynamics of how it falls. And then this last piece is just so awesome. Nature has only one department and only one language. Now, only one language, that's pretty interesting, and I wonder what that language is, but only one department is kind of an indirect jab at the university or the academic system, where we have all of these different departments with their own career hierarchies, their own knowledge silos, their own methodologies, their ways of talking about the same exact phenomena. And so in a way, synergetics is kind of like complexity or like systems thinking, because it's the unifying framework by which we can just talk about nature and not have to worry about which discipline we're in. And by doing so, we actually bring a lot more people into the conversation. It's not just an academic conversation, which is fragmented into departments. 92. These thoughts kept stimulating my explorations for the totally accommodative coordinate system. Einstein's conclusion that the definitive maximum possible speed of light rendered astronomical phenomena an aggregate of non-simultaneous and only partially overlapping, differentially enduring energy events, greatly affected the increasing inventory of my tentative formulations of the interaccommodative requirements of the cosmic coordination system which I sought. I was driven by both consciously and subconsciously sustained intuition and excitement. This was very private. However, I talked to no one about it. It was all very remote from that which seemed to characterize popular interest. So a few things happening here. First is that light has a speed, and the fact that light has a speed is really different than light being instantaneous, because this means that stars, which are in different places, astrological phenomena, can be seen as sort of like emitting these radiating shells of photons, but we can think about that in a little bit more general sense as well. And that means that wherever two photons meet, somewhere on Earth, looking at the Big Dipper, for example, those are happening at the same time for the observer, but they're not necessarily happening at the same emission moment for those stars. And that idea of a non-simultaneous universe, or one that's simultaneous locally, but not necessarily distally, is something that connects the relativity sense of 4D and Einstein explicitly back to synergetics and Bucky. And the second piece here is that Bucky kept it private. Now, whether Bucky is being coy here or whether telling a parable of his life rather than how it actually was, seems kind of true. And just this notion that what one keeps private can be very important, and that which characterizes popular interest is not always the most important thing for us to follow. So, kind of like follow our heart, but Bucky's speaking through his own life. 93. The youthful accruals of these long-sustained private observations, cogitations, and speculations were enormously helpful when I decided at the age of 32, in my crisis year of 1927, to abandon the game of competitive survival, a game I had been taught to believe in as thought out, managed, and evolved entirely by others, and instead to rely completely upon my own thinking and experience-suggested inclinations, to find out how universe is organized and what it is doing unbeknownst to humans. Why are humans here in universe? What should we be doing to fulfill our designated function in universe? Surely all those stars and galaxies were not designed only to be romantic scenery for human moods. What am I designed to be able to comprehend about universe? What are we humans designed to be able to do for one another and for our universe? Pretty interesting quotes here. So again, the weaving of his own experience, his own crisis when he was at the age of 32 in 1927 AD, with some of the eternal questions, things that people and maybe even non-people have been asking forever. Like, why are we/I here? What are we doing in universe, and what is our functioning? What is our function? And as usual, just ultra deep philosophy in his own words, mixed in with kind of jokes. Maybe it is about the romance. Who knows? And also these last questions. What are we humans designed to be able to do for one another and for our universe? It's almost a JFK-ism. You know, ask not what others and the universe can do for you, but what you can do for others and the universe. So this search for nature's coordinate system is how he's framed it here. And we'll kind of give an overview soon, but we want to know if nature only has one department and one language, so take that as a working hypothesis or a supposition for now, we want to be using that language. If nature only has one way of coordinating, and it's interaccommodative of the convex and the concave and the radiating and the collapsing and all these different things that appear to be different languages or are studied or discussed in different departments here in our current way of thinking, we want to be able to have a system that's more in line with nature. And so if it turns out that nature stacks spheres in a close packing arrangement, hint, hint, rather than packing voxels or blocks, well, we might want to think about how we could consider changing our mathematics to reflect the language and the department structure that nature uses, which is integrative and interaccommodating, rather than the one that maybe we grew up with or that we initially felt most comfortable with for some other reason. 94. Expanding universe. My determination to commit myself completely to search for nature's raison d'etre and for its comprehensive coordinate systems mathematics was greatly reinforced by the major discovery of the astronomer E.P. Hubble in 1924. He discovered an expanding macrocosmic system with all the myriads of galaxies and their respective stellar components at all times maintaining the same interangular orientations and relative interdistancings from one another, while some totally and omnisymmetrically expanding and moving individually away from one another, and doing so at astronomical speeds. This discovery of Hubble's became known as expanding universe. So Bucky's bringing in some findings from the big, things that are bigger than we are, astronomical speeds. It doesn't matter what they are, they're astronomical. And we're going to be also thinking about things that are smaller than us, like nuclear structure. Why? Because nature only has one department. So maybe particle physics is studied over in this building, and biology is over in this building, psychology over here, philosophy over here, and astronomy over here. But if nature only has one department, then we're going to be kind of mixing those in a way that you might not see in, for example, a course as taught in, say, current year. And this is something that if somebody has more experience with astronomy or even astrology, maybe come help us out. How can it really be that things are expanding away from each other and that the relative distances are being conserved? Is that the case? Is there a piece of evidence that might show that to be not true? 95. The only way humans can expand their houses is by constructing lopsided additions to the rectilinearly calculated contriving. People found that they could blow up rubber balloon spheres to increase their radii, but they couldn't blow up their buildings except by dynamite. They called their wooden 2x4 and 2x6 and 2x8 inch cross-section wooden timber nail-ups balloon framing, but why they selected that name was difficult to explain. So he's referring to this idea that when things are spherical, they can be expanded in a way where if you put little points on all over the balloon, little Sharpies, mark on the balloon, as you blew up the balloon, it would expand equally. So that's kind of the expanding universe idea. It's kind of like this inflating balloon. But how do we expand our buildings? Well, it's kind of ad hoc. It's lopsided. Like, let's just add a wing here, or let's add a new room over here. And then we pretty much can't just expand them. We have to destroy stuff, and then we have to do ad hoc additions. So that doesn't seem to be the case for how nature does it. When we grow bigger, that's not the case. We're not just adding a new piece onto ourselves, and it's not how universe seems to be working. So that's what is motivating Bucky. He's drawing in all these different patterns, because if there's a pattern A at level A, pattern B at level B, pattern C at level C, we kind of want to have a general conceptual framework, Synergetics, that actually looks for pattern A, B, and C in each of the levels. Now, maybe they're less important in one level versus another, like gravity being really important in one space versus less important at a different scale or for a different system, but it's inter-accommodating. It still accommodates all these differences. 96. My insights regarding nature's coordinate system were greatly enhanced by two of Milton Academy's greatest teachers, Homer Lesurde in physics and William Lusk Webster Field, Biology Bill, in biology. During the summer vacation of 1906, at 11 years of age, I designed and built my first small but exciting experimental dwelling on our family's small mid-Penobscot Bay island. Living all my youthful summers on that island, with its essential boat building, boat modifying, boat upkeep, and boat sailing, followed by 5 years as a line officer in the regular U.S. Navy, with some of my own smaller craft commands. Some deck officering on large craft of the new era's advanced technology, ships, together with service involving airplanes, submarines, celestial navigation, ballistics, radio, and radio telephone. Then resignation from the Navy, followed by 5 more private enterprise years, developing a new building system, inventing and installing its production tools, managing the production of the materials, and erecting therewith 240 residences and small commercial buildings, altogether finally transform my sustained activity into full preoccupation with my early boyhood determination someday to comprehend and codify nature's omni-intertransformative, omnidirectional, cosmic coordination system and its holistic, only experientially proven mathematics. In 1928, inspired and fortified by Hubble's expanding universe discovery, I gave the name and its symbol 4D to my mathematical preoccupations and their progressively discovered system codifying. In 1936, I renamed my discipline Energetic Vectorial Geometry. In 1938, I again renamed it to Energetic Synergetic Geometry, and in 1970, for verbal economy, contracted that title to Synergetics. Here's figure 986.096, 4D symbol, adopted by the author Bucky Fuller in 1928 to characterize his fourth-dimensional mathematical explorings. So I kind of went down several rabbit holes today preparing for this. One of them was If Bucky came up with 4D in 1928, so 1 year after his crisis year of 1927, which is what he talked about in section 93, 1 year after his crisis, he comes up with 4D, which he is saying is part of a continuous story of his early preoccupation with codifying nature's coordinate system. So he comes up with 4D early. And I asked the Trim Tab reading group and all of the really tremendous knowledge and generosity with the time of all those participants, said, what did Bucky know about 4D then? Was he talking about Einstein? Was he talking about geometry? Was he talking about tetrahedra? So what did Bucky know about 4D when? And that's going to be for another Synergetic stream. And then the other piece that will be also for another Synergetic stream is he said that he spent 5 years in the U.S. Navy, and then he resigned. But in some of the brief readings that I could find, at least from the military history resources that I looked at, it looked more like less than 5 years, and maybe he was discharged, not resigned. So, 2, 5, discharge, resignation. I mean, come on, what's it matter? But it does really matter. So potentially we might look through some original documents, but this is an important part of Bucky's life history. And so I really hope to learn more about it, whether we need to do a Freedom of Information Act request, a FOIA request, or anything else. This is information that I will seek out. So I'm not going to go into the U.S. Navy or exactly the 4D pieces here, but this is just such an interesting section of text. He links his childhood, his boyhood education at the Milton Academy, which I looked at. I'm not going to make any slides on it. The Milton Academy and some of his great teachers, just like we've all had really great teachers through his career in the military and private enterprise, and connects it through and through to decades and decades later as he increasingly shortened the title of what this unifying system is called. So today we're calling it Synergetics. But there in the name, we can see all the pieces that matter: energy, vectors, and geometry. And then the vectors become integrated into the synergetics, which is, we're going to talk about that in the considerations. And then he contracts it again for efficiency just down to synergetics. So this is sort of how 4D, codename 4D, becomes synergetics as we know it, and the insights that he has along the way. And so just like we have the specifics in the general, there's always like the aspect of change, and the more things change, the more they stay the same. So Bucky is still just that boy in his early childhood, determined to comprehend and codify how nature can be intertransformative. How can everything be transforming in and out all the time? How can oxygen and carbon always be in this intertransformative way of operating with each other? How can shapes be always turning inside and outside? How can it be going in all directions at once? How can it be happening at the cosmic scale, at the astronomical scale, and at the nuclear scale? How can that all be happening and connected to our experience and formalisms? So setting up some big challenges, but that's what Synergetics does. And it's worth it just to full screen that 4D, because it's such a interesting symbol, and D is the fourth letter of the alphabet, so it's kind of like a little battleship reference, D4. And 4D brought up again in those key memes and themes because it really is essential, and it's kind of like a nexus for talking about Bucky, if not starting to learn and understand. So that was the first sequence. Why is Bucky on this quest for nature's coordinate system? Well, nature seems to have all of these different ways of working, radiating and contracting, and doing this and doing that. And so we want to have a system, not just that recapitulates the social structures that our ancestors were familiar with, but we want to have a coordinate system, a sense-making system, a framework for comprehension that is aligned with nature. And we can pick up cues on what might make it aligned with nature from big systems, from our own psychology, from systems smaller than us. So we're going to be looking again in all these places that don't map neatly onto the academic way of thinking per se, and connect that specifics and the general, and we're just going to call that 4D. So, Section 100, Sequence of Considerations. At the outset of my lifelong search for nature's omni-rational coordination system of mathematical interaccounting and intertransformability, I proceeded through a sequence of considerations, which may be enumerated as follows. So, as with many stories with Bucky, was this something that he thought of when he was young? Because the outset of his lifelong search probably was when he was a child. Well, yes and no. It's sort of in Kairos, not in Chronos, were these considerations important in this sequence. So this is not per se 7-year-old Bucky or 11-year-old Bucky, but perhaps Bucky as that 4-dimensional caterpillar or 5-dimensional or whatever the reality is. It's him in the integral form, considering it in the deepest possible way. And for most of the rest of the discussion today, we're going to be looking through these 9 considerations. And there's also a 10th consideration in section 200, but not going to go there right now. The 9 considerations that we're going to talk about are energetic vectors, Avogadro's constant energy accounting, angular constancy, isotropic vector model, closest packing of spheres, diametric unity, vector equilibrium, concentric polyhedra hierarchy, and synergetics. So for each of these sections, ask yourself, what are we considering and why? Why is there a sequence of considerations? What does the sequence represent, mean, or do? What other sequences or listed items are relevant? We talk a lot about zooming out to universe and then zooming in by progressively discarding irrelevancies. So how do we go out as big as we can think, as big as we can imagine, and then go to those minute particulars by discarding what's irrelevant? It's almost like Bayesian model reduction, but Bucky didn't know that. And what other considerations do we want to add? This isn't a finished story. The synergetic trajectory is moving through you if you're paying attention to it and if you're choosing to have it move through you. So what other pieces can we add onto this sequence? What mutations? What appendages? How can we rethink this sequence of considerations? And do we often take the time to really stop and go through an appropriate sequence of considerations before we set out on a conversation or a project? So it's just really powerful that Bucky frames not just, the kind of listicle, you'll be shocked. Scientists agree on these 9 considerations. This is like something that's thoughtful, that is experiential, rather than just, oh, okay, well, other people agreed upon these 9 important things. All right, believe them. These are all things that are for us to consider. So even if some of these words look a little esoteric, let's think about how we can experience them and re-experience them. All right, section 110 for the first consideration of energetic vectors. 111. I first determined to employ only vectors for lines. I realized that operationally, all lines are always trajectories of energy events, either as the energy invested by humans in the work of carving or depositing linearly, which we call drawing, a line, or as the inanimately articulated energy of forest lines. So just like we talked about in the very beginning, point, line, and plane, great book by Kandinsky as well. They're going to have a little bit of a different sense here. So let's just think about a line like a trajectory. A lot is different between the sort of lifeless, static line on the chalkboard and this sort of dynamic conception of a line. It's like even looking at that line on the chalkboard, think about the human who made that trace. So we're going to realize that lines, whether they're something that is moving, well, it's obviously dynamic, or even a static line, is reflecting the trace of something that was dynamic and left a mark, stigmergy. And that is going to percolate through all of the rest of the thinking. So there's other places where Bucky critiques other notions of lines, like the idea that they're parallel and they go off forever. But here, we're realizing that lines can't just be like 3 inches long. They have to have a dynamic. And yes, their length can be X, but there's a dynamic where a balancing set of forces led to it having that length in appearance. And also, it's just so cool that first consideration, first quote, drawing. So really empowering our own experience, us scribbling on the page. 112. Vectors always represent energy forces of given magnitude operating at given angles upon given entities at given loci. And vectors may always be demonstrated by lines representing given mass moving at given velocity in unique angular direction in respect to a given axis of observation. Vectors do not occur singly. They occur only as the total family of forces interacting in any given physical circumstance. So here we're going to get really specific, like what are the degrees of freedom when a vector is being specified? It's always going to be some specific angle and some specific length. When we talk about line in the abstract, it's like could be over here, could be over there. If it's going off into infinity, we kind of might be clustering things that we don't actually mean to cluster, where we take two particulars and, oh, well, they're both lines. And so they're linked in a way. There's certainly analogy or there's resonance, but we don't always get this full explication that there's so many degrees of freedom and so many specifics in each line when we choose to interpret them as vectors. So that's this first point, is vectors take this abstract concept of line and it brings everything into the dynamic specifics instead of the static generals. So again, we're going to be looking for generalizations and for universal patterning, but we're going to be thinking about that in terms of only manifest particulars. And the second point is that vectors do not occur alone. Like the movement of a ship, a vector of a ship in its directionality, which is something that Bucky studied a lot, is always related to a family of forces. So why is the vector not longer? Well, because there's something pushing up against it so that the net resulting vector is so and so long. 113. Vectors always have unique length. That length being the product of the mass and the velocity as expressed in a given modular system of measurement. Vectors do not have inherent extendability to infinity, as did the lines of my boyhood's school teachers. Vectors are inherently terminal. Vectors bring into geometry all the qualities of energetic reality lacking in Euclidean geometry. Time and energy differentially divergent as radiation, velocity, and energy integratively convergent as matter, mass. Velocity and mass could be resolved into numerically described time and temperature components. So a couple things here. The first part is a restatement in a way of 112, which is that vectors have certain parameters, certain specificities, and specifically, one of their parameters is their length. So just like time must have a stop, Huxley, vectors must have an end. A vector of infinite length doesn't exist, despite what Bucky was taught as a child. Vectors bring into geometry all the qualities of energetic reality lacking in Euclidean geometry. So when we look at these proof books of the classical geometers, it's kind of static, like the Pythagorean right triangle proofs. They're timeless. They're classics, of course. But the edges of the triangle don't have a variable for t, for time. How do we bring in this element of time and momentum and dynamicism? Well, Bucky's saying it has to do with vectors. So even when we're looking in something like a tetrahedra or some other shape, some other polyhedra, some other polyvertexion, all the edges are interpreted as dynamic, energetic edges between energy events. And it can be energy that's being pulled in, contracting, like gravity, or it can be energy that's radiating out, like a photon going out of an energy event, like a star. But what can't it do? The edge just can't be sitting there statically, timelessly. So even when we're looking at static pictures, like when we're reading the physical synergetics or when we're looking at these images here in these streams, we're always thinking about energy events happening at specific times and vectors, which can be either radiating out or pulling in, as being all about their specifics and with a dynamic. This was something that I wasn't totally sure about, but it's really interesting to think about, which is the idea that the energy could be differentially divergent as radiation velocity. Okay, so I thought, okay, sound has a speed, and then like light has a different speed. So I can see how speed has something to do with radiation. And then energy integratively convergent as matter and mass. So maybe that has to do with like inertia. So there's something that's sort of slowing it down or making it more solid, and that there's this mass energy, matter energy relationship. Velocity and mass could be resolved into numerically described time and temperature components. So then, okay, velocity, time. Velocity has time in it, miles per hour, kilometers per hour. So time's kind of in there. How is mass related to temperature? Something fun to think about. So that was the first consideration. So this is kind of like the synergetic pilling of a listener. How do you convert someone to synergetics? First consideration. Now, not to say that this is the best rhetorical pathway. I'm sure that many exist and many remain to be discovered. But when we're thinking through from first principles, why synergetics? These are a sequence of considerations. What is the first consideration that Bucky decided to put? Energetic vectors. So first consideration, the universe is energetic. And so even when we draw a line, we have to remember that it's terminal, it must have an end, and it must have a dynamic energy component. So already we're in a different world than just sort of a squared plus b squared equals c squared. That's consistent within this dynamic energetic world. Consideration 2, 986.120. Avogadro's constant energy accounting. 121. Avogadro discovered that under identical conditions of pressure and heat, all elements in their gaseous state always consist of the same number of molecules per given volume. Since the chemical elements are fundamentally different in electron-proton componentation, this concept seemed to me to be the grand central station of nature's numerical coordinate system's geometric volume, that numerically exact volumes contain constant, exact numbers of fundamental energy entities. This was the numerical and geometric constancy for which I was looking. I determined to generalize Avogadro's experimentally proven hypothesis that under identical conditions of heat and pressure, all gases disclose the same number of molecules per given volume. See sections 410, 3 and 4. So many of us have probably heard of Avogadro's number, 6.022 times 10 to the 23rd. And this is sort of hinting at both Avogadro's number as well as the ideal gas law, PV equals nRT. And Bucky brings a few things together here. First is that the chemical elements, which differ in their makeup of protons and electrons and neutrons, the periodic table, what is the invariant? What is the similarity across the periodic table as well as even molecules that are linked up with more than one atom? Now, the ideal gas law turns out to have some asymptotic characteristics, and I'm sure there's some complexities there with big molecules, but in the limit, the ideal gas law is a pattern that is true. And this concept is the grand central station, the nexus, nex. This is where we get a relationship amongst things that seem radically different, like hydrogen or neon, and integer numbers. Avogadro's number is an integer. There is a number where if you had one more hydrogen jump into that flask, you'd go more. You'd be over this number, and if you had one taken away, it'd be less than that number. So it actually kind of gives us like a meter stick. So one atomic unit of mass, it's actually a little bit arbitrary. I think it has to do with like carbon 12 divided by 12. But Avogadro's number is saying that there is some sort of like integer relationship that holds invariant across these different energetic patternings. So why is that Grand Central Station? Let's find out. 122. Here were physical universe's natural number quantations being constantly related to given volumes. Volumes are geometrical entities. Geometrically defined and calculated volumes are polyhedral systems. Polyhedra are defined by edge lines, each of which must be a vector. So we're going to work backwards from physical universe, integers, whole number accounting, through abstract geometrical shapes, back to that energetic vectorial geometry. These are natural numbers, quantations, calculations. And PV equals nRT, the ideal gas law, Avogadro's number, is connecting integer mathematics, integer calculations, to volumetric considerations. Volumes are geometrical. They actually have to have not just topology, not just connectedness, but actual volume enclosure. That's what the V in PV equals nRT is. Okay, so we're talking about volume. Volume has to have geometry. Geometry means polyhedra. Now, it might have many hedra, many faces. It could have many vertices. Maybe it's a regular polyhedra. Maybe you're doing cool chemistry in a really interesting shape, which we might get to at the end. Or maybe it's an irregular polyhedra. But the point is, when you're talking about physical volume, you're talking about shape. And what about those shape? Well, they have edges. And those edges, remember from the previous consideration, we're going to think about dynamically. So here we are connecting periodic table with geometry, integer mathematics, dynamic vectors. 123. Within any given volumetrically contained gaseous state, the energy kinetics of molecules are everywhere the same. The outward pressure of air against the enclosing tube wall and casing of any one automobile tire is everywhere the same. Pressure and heat differentials involve isolated conditions, isolated by containers, ergo special cases. To me, this meant that we could further generalize Avogadro by saying that under identical, uncontained, freely self-interarranging conditions of energy, all chemical elements will disclose the same number of fundamental somethings per given volume. This constant volume, population, and omni-equilibrous energy relationship would require physically demonstrable, substantive, geometrical combining of a given number of unique energetic events, entities per unit volume, with constant angularly defined positional orientation integrities. This meant that the vectorially structured shapes of the volumes accommodating given numbers of most primitive energy events must be experientially demonstrable. A lot that could be said here, for example, the translation of sort of ergodicity assumptions, dare I say, active community, don't freak out. But the idea that there's sort of a similarity of pressure or a similarity of the energy kinetics within a given system defined. Another piece that's nice to note is that Bucky's generalizing Avogadro. So we're not just talking about pressure and volume of gases, but maybe that if we allow this sort of identical and independently distributed IID, if we allow that to be the case, there'll be the same number of somethings. What is that something? Well, whatever it is, it's going to be definite. It's going to be physically demonstrable and substantive and geometrical. Just like we talked, it has to be geometrical if there's volume and real matter getting involved. That means that the vectorially structured shapes of the volumes, so again, the edges are energetic because if it has volume, it has shape. And if it has edges, it has energy, it has these energetic vectors, first consideration. And that means that any given number of the captioning stopped. I'm going to just quickly see if the captioning can be recovered. If not, C'est la vie. Weird, but really so it goes. Streaming is fun like that. And we're back with the Shroomies fun like that. Oh, Google Voice. This connects us back through all these different areas. So thinking again, integer mathematics, chemistry and physics, information and thermodynamics, into the geometry and the vectors, and then back to experiential demonstrability. That's what this tells us. Consideration 2. So consideration 1, think about lines as energetic. Points are energy events, and lines are like energetic vectors that are terminating finitely. And then consideration 2, think about Avogadro. If you have some sort of a coordinate system for nature or some sort of accounting system for nature that just allows you to fractionalize forever infinitesimals, then where does Avogadro's number come from? And then let's just step away from that and think about this constancy that Avogadro's accounting seems to be moving us towards, and then maybe even generalize that and bring it back to our own experience. 986.130. Consideration 3, angular constancy. 986.131. I said that since vectors are physically modelable structural components, they produce conceptual structural models of energy events. And since my hypothetical generalization of Avogadro's law requires that all the conditions of energy be everywhere the same, what does this condition look like as structured in vectorial geometry? Obviously, all the vectors must be the same length, and all of them must interact at the same angles. I said, it will make no difference what length is employed so long as they are all the same length. Linear size is special case. Special case occurs only in time. Angles are cosmically constant, independently of time size considerations. Let's jump to this word hypothetical. So again, this isn't a list of 9 facts that Bucky's going to tell you and you can't disagree with. This is a sequence of thoughts, and we're not going to lie to ourselves about what is, quote, empirically a fact versus what is a hypothesis, what's a thought experiment. We can just be clear about it and move forward. He's saying it's a hypothetical generalization of Avogadro's law. So whatever we think about laws of science, does nature have laws, whatever it happens to be, this pattern that we described about Avogadro's number and about the relationship of the ideal gas law, there's something in there that we want to generalize, which is like, if we have this well-mixed gas, that's how a lot of thermodynamics begins. Again, non-equilibrium thermo, maybe it takes it a different direction, but we have these assumptions of well-mixedness, or we have this idea that in the automobile tire, in the car's tire, that the pressure on all parts is the same. Like on a balloon, it'd be kind of weird if there was like a little lump reflecting higher pressure, and then there was a different part reflecting lower pressure. Now, if the balloon had thicker part and a thinner part, it might have a shape like that. But actually, that shape would be making the same pressure everywhere, because some parts would be pulling in with more strength versus not. And so you get an irregular shape, but the pressure would equilibrate. So just take it slow and think, okay, how do we move from that balloon expanding, which also invokes that expanding universe, the balloon model we talked about earlier. How do we go from that sense of volume being something that integrates pressure in a way that is similar everywhere? How do we take that into geometry? And not just this dead static geometry, but vectorial geometry. So these edges, they look like lines or segments of lines, but don't be confused. They have energy in them. And so we're going to be thinking about them along the lines of the first consideration. Bucky says, obviously all the vectors must be the same length and all of them must interact at the same angles. So it's kind of like a symmetry group. There's probably a lot of ways that people could think about this, but just like in the automobile tire, if the tire is homogeneous, then the pressure everywhere is going to be homogeneous. Now we're thinking, okay, we're going to talk about geometry. We want all the angles to be the same. So if you have the same angle, I'm not even going to say what number it is because it could be in degrees, it could be in radians, maybe it's on a sphere. When all the angles are the same, there's only a few options for those shapes. One we call an equilateral triangle in, quote, 2 dimensions. And then that doesn't enclose any volume. You can't have a physical triangle. You can have stuff that looks like a triangle. I have tons of them all over the house, but it isn't until you reach the so-called 3rd dimension where volume becomes enclosed with a tetrahedron, tetravertexion, that you are able to have something that can truly be special case in our world. Angles are cosmically constant independently of time size consideration. Pythagoras, a squared plus b squared equals c squared for the right triangle with a 90-degree angle. Why is time not in that picture? And why are we able to generalize A, B, and C instead of saying like 3, 4, 5? Because it's about the angles. So angles, ratios, rationation, thinking is independent of the special case. So this is something that comes up all the time. Angle is like patterning. It's general. And length, remember the vector, it has to be like 20 inches or 75 miles. But whatever it is, it's a specific thing. And in a specific place and time because it's either radiating out or converging in from an energy event. And so angle is what moves us away from the specifics of time and size. And then how do we take this invariance that we saw in Avogadro's number and the ideal gas law, applying it to vectorial geometry? Well, it should be the case that all the angles should be the same and all the edges should be the same length as well, but that's sort of secondary to the angles being the same. Consideration 4, isotropic vector model, section 140. 141. I said, can you make a vector model of this generalization of Avogadro? And I found that I had already done so in the kindergarten event in 1899 when I was almost inoperative visually and was exploring tactilely for a structural form that would hold its shape. This I could clearly feel was the triangle with which I could make systems having insides and outsides. This was when I first made the octet truss out of toothpicks and semi-dried peas, which interstructuring patterns scientists decades later called the isotropic vector matrix, meaning that the vectorial lengths and interanglings are everywhere the same. So, a few things. So first, this is kind of a classic book and saying. All I really need to know, I learned in kindergarten. #1 international bestseller. That was definitely up in some of my early childhood classrooms. But everything Bucky needed to know, the rest was just details. After kindergarten, after he invented the octet truss and got all excited about the nature's coordinate system. But it's also something to note that he describes himself as almost inoperative visually. Now, I'm not an expert on this part, but Bucky had some sight limitations, and this was poorly understood or diagnosed. And so he was using his other senses. He was exploring tactilely for a structural form that would hold its shape. So somebody who could see a house, like a rectangular house, a sort of, let's just say, traditional Western architecture, they look at it, looks like a box. Okay, well, it's standing and it looks like a box. So maybe boxes have structural support. And, they also fill space. You can pack the shipping containers. So I don't see any issues with XYZ world. But when Bucky was playing with these physical objects, he was searching for what wouldn't collapse. And if you just make, 4 marshmallows connected by toothpicks, the square is going to just fall over. What is the shape that can't fall over? Well, it's the triangle. You can't fold it in anymore until the toothpick breaks. And then if you take that into the so-called 3rd dimension, you get the tetrahedra. So this speaks to so many things about exploring with our different senses, about recognizing our differences in capacity, as well as directly experiencing and listening to children, and then connects that, again, general, specific, his life, our lives, everything coming together decades later the octet truss, and the isotropic vector matrix, which is something we're going to talk about a lot. 142. This matrix was vectorially modelable, since its lines, being vectors, did not lead to infinity. This isotropic vector matrix consists of 6-edged tetrahedra plus 12-edged octahedra in multiples of 6. Here is an uncontained omni-equilibrous condition that not only could be, but spontaneously would be, reverted to any when and anywhere as a 6-dimensional frame of transformative evolution reference, and its vector lengths could be discretely tuned by uniform modular subdivisioning to accommodate any desired special case, wavelength, time, size, most economically interrelated transmission or reception of physically describable information. Compare section 639.02 and 1075.10. So in the coordinate system of XYZ, the Cartesian system, the lines go out into infinity, which doesn't happen in a sphere, doesn't happen in a polyhedra, and it doesn't happen in curved space-time potentially, to bring in that Einstein connection. What's cool about the isotropic vector matrix is that it can tessellate out as far as you need, but it does so in this sort of incremental way where you can make it as big as you want finitely, but never get to infinity. So it's perfect for people who think about finite structures, which is what we're encouraged to do. And this is something I'm not sure exactly what is meant here with a 6-dimensional frame. That'd be cool if anyone has thoughts on that. Definitely, like, we talked about 4D, 6-dimensional, what? Does that have to do with the octahedra? And another piece here is that the vector lengths, so the edges of the tetrahedra, can be discretely tuned by modular subdivisioning to accommodate any desired special case. So vectors are always special case. So we kind of have this field, this patterning that can be tessellated out, expanded out as far as we want, but also we can make it like bigger or smaller on the edges. So kind of scale it in or out in a way that's continuous. And then once we've locked in the IVM, the isotropic vector matrix, with a special case edge, all the edges are the same length, we can then subdivide. And so that's kind of zooming out and zooming in, and we talk about the frequency of shapes. So you have the tetrahedra, and then here's my desk tet. You can make higher frequency shapes, and that's done by subdividing the edges and inscribing shapes inside of that. 143. Since the vectors are all identical in length, their intersection vertexes become the nuclear centers of unit radius spheres in closest packed aggregation, which closest packing is manifest by atoms in their crystal growth. All the foregoing brought the adoption of my vectorial geometries everywhere the same, isotropic, vector matrix as the unified field capable of accommodating all a physical universe's intertransformative requirements. So in a way, consideration 1, 2, and 3 brought us to the construction of the isotropic vector model. We're going to talk about how it relates to close packing of spheres more in the consideration 5, but we're thinking, okay, the angles are all the same and the edges are all the same length, and we think about edges in terms of vectors. We also want it to be finite from what we learned from Avogadro and geometrical. So that's dynamic, energetic, vectorial geometry. We want to have this sort of angular invariance. And now we've created a field or a matrix that is interaccommodating. It supports these fundamental patterns of nature. And so that's the isotropic vector matrix. It's the unified field capable of accommodating what we need. It's what we crave, is the IVM. this is what we're going to use. So we can have one sort of extreme model, XYZ, and it's sort of the Minecraft world, XYZ and the voxels. And then on the other side, so that's cube-centric. No, I don't want to say face-centered cube. It's that it's cube-based. The shape that the axes block off is a block. It's a voxel. It's like a rectangle or it's a cube. And the edges go off to infinity. So strike 1, infinity. Strike 2, cubes. Strike 3, static lines going off to infinity, not energetic vectors that have a terminus. Let's go for the model that actually fits reality. How does that sound? Something that has angular constancy, something that respects finite universe and finite systems especially, and that respects energetic geometry. That's the IVM. A lot of the rest of Synergetics can be seen as almost the consequences of adopting the IVM, but it's not the only way to eat this body of knowledge and digest it, but just one way that these considerations are somewhat structured. It's kind of like a hero's journey with the recognition of the need progressively for an isotropic vector model. And then he says later it was called the isotropic vector matrix. So they're both IVM. But just like isotropic is used in thermodynamics and other fields, which means the same everywhere, we wanted to combine the insight from the energetic vector consideration with this sort of Avogadro's isotropic insight in a finite setting. And that's what leads us to the isotropic vector model, which turns out to be this matrix that can go off finitely in an arbitrary but specified duration. And then we can do all this cool stuff like rescaling the distances and introducing higher frequency shapes inside. So that's the hero's journey. We build up this tension on our quest for nature's coordinate system. How does nature make sense of itself? How does nature really work? And we build up to the isotropic vector model. And now we're going to look at some consequences of the isotropic vector model, the IVM, the isotropic vector matrix, some consequences and some corollaries, we might say. How is this different than the sort of XYZ world? The contrasts will make themselves clear. Several have already been mentioned, and I'm sure many more exist. But this is the framework that we're going to be working with. It's not XYZ cubes, it's isotropic vector matrix. What kind of shapes fit in there? What are their edges? What's their volume ratios? That's the fun. Consideration 5, closest packing of spheres, 986.150 and 151. I had thus identified the isotropic vector matrix with the uniform linear distances between the centers of unit radius spheres, which aggregates became known later in 1922 as closest packed unit radius spheres, section 410.07. A condition within which we always have the same optimum number of the same somethings, spheres, or maybe atoms per given volume, and an optimally most stable and efficient aggregating arrangement known for past centuries by stackers of unit radius coconuts or cannonballs, and used by nature for all time in the closest packing of unit radius atoms and crystals. So in this IVM, we can think about the intersection of these vectors as being nuclear centers. So because the vector coming out in each direction is the same length, it's almost like the center point defines a sphere, which is defined as like if you could be in the continuous universe where it sweeps out a perfectly smooth surface where every point on the sphere is equidistant from the center. So here we're just going to think about 12 vectors coming out of that center point. And those 12 vectors coming out of the center point are the kissing points of the spheres. This close packing is really important. When you have a bunch of spheres, they don't align into like this sort of like XYZ grid. They fall into this close packing. And to give just one kind of cool note on this, a paper by L.V. Woodcock in 1997 in Nature, back in the classic days. This is a paper that, and I'll just read the abstract because I think it's actually very relevant. But for a little bit more of a background, There's a good wiki article on the close packing of spheres and the cannonball problem specifically. People were like, how much room do we need to pack coconuts or to pack cannonballs in this ship? What proportion of space is taken up by spheres? Is there a way that we can pack these spheres in more closely? Like, okay, we probably can't get 100% packed by spheres, but can we get 80%? Or what? It turns out there's a specific number. Here's the abstract of this paper from 97. Spheres can be stacked into two close-packed crystalline arrangements, face-centered cubic, FCC, and hexagon close-packed, HCP, which have identical close-packed volumes and very similar equations of state. But they are structurally distinct, implying that they might have different thermodynamic properties and stabilities. Finding a difference in free energy between the two structures has been the objective of much theoretical and computational effort, but without a conclusive resolution. Here I report that a significant difference in the pressure-volume behavior can be detected in the vicinity of a mechanical instability point within a single occupancy model of these packings. The model provides an exact thermodynamically reversible path between the two structures, and so the PV isotherms can be integrated to obtain the Gibbs free energy difference. I find that the face-centered cubic phase is more stable by around 0.005 RT per mole, where R is the universal gas constant, T is temperature, as the enthalpy difference is negligible. This implies that the entropy difference is on the order of 0.005 R for all temperatures up to the melting point. Here's the figure. Why do we see the close packing that we see with a face-centered cubic? Well, there's a lot of thermodynamics behind it, and it turns out that there's just multiple ways that things can be close packed. But here we see a phase diagram, and I just wanted to bring it up because we're always looking for learning and looking for connections between free energy, Tesla, Gibbs, Friston, the classic free energies, free energy in the thermodynamic sense, and then geometry. What is the geometry of free energy, and why do cannonballs pack the way they pack? These are just classic, fascinating questions, and I'm sure there's hundreds of citations for this paper and a lot of other work, but it was just cool to see that only 20 years ago, or however many years ago from when you're listening to this, was the case that some of these very subtle differences between closely alternative packings of crystals were just ever so slightly shown to break one way rather than another. So just kind of cool. I'm not sure of what it all means, but again, if anyone is watching it and knows, they should definitely come on and help us all out. So closest packing of spheres, being part of a free energy minimizing structure. You can stack them very carefully, but it's going to be this unstable equilibrium because as soon as you push, they're going to collapse down to close packing. Consideration 6, diametric unity. 161. The installation of the closest packed unit radius spheres into their geometrical congruence with the isotropic vector matrix show that each of the vectors always reaches between the spheric centers of any two tangentially adjacent spheres. This meant that the radius of each of the kissing spheres consists of 1/2 of the interconnecting vectors. Wherefore, the radius of our closest packed spheres being half of the system vector, it became obvious that if we wish to consider the radius of the unit sphere as unity, we must assume that the value of the vector inherently interconnecting two unit spheres is 2. Unity is plural and at minimum 2. Diameter means diameter unit of system measurement is 2. This is something that Bucky's going to bring up a few more times on this page, later in other pages, yes, on other pages too. Unity is plural and at minimum 2. And that relates to love as gravity and so many other things. If we want to talk about the unit radius sphere, the unit radius cannonball, vector length of 1, so center point of each sphere is going to go out 1 unit. And that 1 unit can be rescaled, but it's a unit length of 1. Then the diameter is 2r. Figure 986.161 shows one vector d whose primitive value is 2. Vectors are energy relationships. First consideration. The phenomenon relationship exists at minimum between two entities, and the word unity means union, which is inherently at minimum 2. Unity is plural and at minimum 2. Also at the outset became a prime concept of synergetics vectorial geometry, see section 540.10. So here we're combining a geometric insight about sphere packing with the relational insight and this idea that we can have unity only when there's difference. You can't, nothing from nothing equals nothing. And you don't get unity, you don't get unification from one thing. One thing cannot be unified if it's itself homogeneous. Unity comes from two things that are unified or more. 163. 1r plus 1r equals 2r. 2r equals diameter. Diameter is the relative conceptual size determinant of a system. A diameter is the prime characteristic of the symmetrical system. The separate single system equal unity. Diameter describes unity. Unity equals 2. See section 95.10 and 113.10. Did I mention that unity is 2, not 1? 164. 1 by itself is non-existent. Existence begins with awareness. Awareness begins with observable otherness. See section 264, 981. This is where we see yet another connection to Friston and free energy principle, active inference. You don't have internal states without external states, and you don't have the separation without the blanket states. Awareness of the other implies integration, unity, but also distinctiveness. So this is a geometrical take, starting from the close packing of cannonballs, on the relational insight, for example, of ecological psychology and active inference. So not always the standard linking of ideas, but that's how we do it in Synergetics. 165. Understanding means comprehending the interrelationship of the observer and the observed. Definitive understanding of interrelationships is expressed by ratios. And here we see figure 986, 161, diametric unity. The vectors of the isotropic vector matrix interconnect the spheric centers of any two tangentially adjacent spheres. The radii of two spheres meet at the kissing point and are each one half of the system vector. Unity is plural and at minimum 2. Oh, did we mention that unity is plural and at minimum 2? Look at them. They're kissing. They're unified. They're experiencing union. And the diameter is 2. From center to center is 2 because each of those cannonballs is a unit radius. So here's a bigger picture on 161 with the kissing point of the two spheres. Oh yeah, did we mention that unity is plural and at minimum 2? I don't want to repeat anything, but you know. Section 166. At the outset of my explorations, I made the working assumption that unity is 2, as combined with the experimentally demonstrable fact that every system and every systematic special case sphere is at once both a concave and a convex sphere. Ergo, always inherently two spheres. Reflective concave surfaces convergently concentrate all impinging radiation, and reflective convex surfaces divergently diffuse all impinging radiation. Though concave and convex are inherently congruent, as they are always and only coexisting, they are also diametrically opposed physical behavior phenomena, ergo absolutely different, because the one diffuses the energies of the universe, producing macrocosmic dispersion, and the other concentrates the energies of universe, producing microcosmic convergence. Concave and convex are explicitly two opposites, co-situated, congruent geometrically as one. This led me to the working assumption at the outset of my thus far 60-year exploration for nature's own coordinate system that unity is inherently plural and at minimum is to be dealt with as the value 2, which two-ness might well coexist with other numbers of inherent properties of primary existent systems. Wow. So first we might note that unity is plural and at minimum 2. We might want to also combine that with another way in which unity is plural and at minimum 2, not just in terms of amplitude of vectors, but the way that every curve has both a concave and a convex side. You can't have a convex curve without the other side being concave, and vice versa. And then the alliteration is just amazing and awesome when we see that the reflective concave surfaces are convergently concentrating, and then the convex surfaces are divergently diffusing. So when we convergently concentrate, we get microcosmic convergence. When we divergently diffuse, we get macrocosmic dispersion. So that's sort of like explosion versus implosion. And again, just connected to his own journey and quest for nature's coordinate system. So there's multiple different domains where we see unity being plural and at minimum 2, and Bucky is generalizing even beyond that to suggest that maybe that's related to other primary existence systems. So that was consideration 6. We're talking about the unity, the key vector length is 1. We're rescaling to 1. We saw that kind of traces out a sphere, although there's only 12 points because the 12 balls around the nuclear shell. And then that makes this distance between the two centers of the spheres 2. And then, so that's one way in which unity is plural at minimum 2. And then there's this other way with the convex and concave, and there's other ways too. Consideration 7, vector equilibrium. 171. I then identified this closest packed sphere's isotropic vector matrix as a generalized field condition of the everywhere and everywhen most economically interaccommodating of any plurality of nuclearly convergent divergent, importively organizing and exportingly info-dispensing energy events, while also providing for any number of individually discrete, overlappingly co-occurrent, frequency differentiated info-inter-exchangings, ergo, to be always accommodative of any number of co-occurrent individual pattern integrity evolutionary scenarios. So, the IVM is our generalized field condition. Why? Well, one reason is it's the most economically, the free energy minimizing and space filling maximum. It's the most interaccommodating way that we can talk about convergence and divergence together. It also provides a scaffold for us to specify any co-occurring individual pattern scenarios that we want, special cases systems. 172. Thus, the eternally regenerative universe, embracing the minimum complex of intercomplementary transformations necessary to effect total regeneration, becomes comprehensively accommodated by the only generalizably definable scenario universe as the condition of vector equilibrium, an almost everywhere everywhen condition, at which nature refuses to pause, but through which most economically accommodating field of operational reference she pulsates her complex myriads of overlapping concurrent local intertransformings and aberrative structurings. I then invented the symbol to identify vector equilibrium. So it's cool because in the active inference world, VE is the variational ecology. So quite a coincidence. VE is the vector equilibrium here, and here's what the shape looks like in Google Slides. Vector equilibrium is going to be just this sort of 0 point. It's sort of this point which Bucky is saying the pulsation is moving through. What does that really mean, and how is it related to the IVM? Let's look at some other resources. Here's from thevectorequilibrium.blogspot.com from 2012. That's somebody who you can trust. They wrote, the vector equilibrium system, you can trust them on this topic, let's say, or can you? The VE system has 12 vertices. Again, those are all the same length, coming from a nuclear center, and they're going out in the same length, and they're kind of tracing out 12 points on the sphere. And so those 12 vertexes make up the VE. 8 triangular faces, 24 edges, and 32 planes. It is an omnidirectional equilibrium symbolically and physically speaking. Thus, it is a perfect symbol for holding the tension of the opposites or uniting the opposites. Yet it is more than a metaphor. It is an archetypal image which connects the matrix with the universe or universe with the matrix. So here's the nice image on their site. Pretty cool. It's that shape in the middle with the triangles and the squares. And that's yet another case of unity being plural and at minimum too, is tension and compression, tensegrity. That's how we do it. Here's another way that somebody else wrote on cosmotry.net on their page, vector equilibrium and isotropic vector matrix, just really showing you that the IVM and the VE are like coexistent. Like the IVM is that space filler, and then the VE is if you just focus on the point in the center and then the 12 vertexes around it with a unit length 1 vector connecting it. With all vectors being exactly the same length and angular relationship from an energetic perspective, consideration 1, the VE represents the ultimate and perfect condition wherein the movement of energy comes to a state of absolute equilibrium, and therefore absolute stillness and nothingness. So cool. So it moves and it moves not. It's sort of the zero still point and the 0 point energy. Now from this site, Latus and Presens, this is a image about the VE, the cuboctahedron, which is the shape that it makes. I hope I'm not messing up any of these shapes or anything. And talking about the jitterbug, which maybe we can talk about in another discussion. But the cuboctahedron can fold through the icosahedron into the octahedron and fold again into the tetrahedron. And so there's this like breathing of in and out, in and out. Really cool. Now here is another page on this Latus and Presens site. So whoever you are, I hope that you might be able to eventually find this because I really appreciated your work. They wrote, and this was a 2021 clarification, which is, I think, the year that I'm in right now, right here. They wrote, the so-called jitterbug dynamic relates solely to the transformations between cuboctahedron, icosahedron, and octahedron in the upper left image of the image above. There are many accessible videos of this dynamic. For example, Bucky's jitterbug, Bucky explains VE. One physical model by which this dynamic can be observed through its manipulation is named jitterbug. However, the model also allows related forms in 3D and 2D, 4D, to be explored through its manipulation, most obviously by variously overlapping its triangular features. It is these additional forms which feature in other portions of the map above and in that below. As above, so below. Come on. A complete mapping could most usefully be articulated by algorithmic manipulation of the structure in virtual reality. And here's some other pages on their website which are well worth looking at. Absolutely. Here we see the VE up on the top, and we see how the jitterbug is connected to all of these shapes and how they flow in and out of each other. So here's, I believe it's this trace. It might be. I think you can see that. Yeah. VE, icosahedron, octahedron, and then you can trace out. I really look forward to a better developed computational synergetics. And I know that many in the community are working on this, but as this person discusses, whether it happens through algorithmic manipulation of the structure in virtual reality, or whether we use computational ontology to relate these so that we can do proof checking like with Sumo on the relationships of shapes, others will know more and better than me for sure. And I hope that they can communicate that information to the rest of us, because this is epic and it's really a cool way to look at the shapes. And it's something I've tried at low throughput to do. And wait, okay, this shape can become that shape and this one goes this way. And you get all the post-it notes and the red yarn. Having something that would be elegant and help us understand like a roadmap kind of for our own sense making, really. Like, okay, I'm at the TET. What can I do? Well, if I go this way, I can go to here. If I go that way, it's 2 stops to here. And if we go, that would just be so epic, because there's a lot of cool things that might be described for one shape but not another, but then they're actually like intertransformative. So, awesome work, latest and presence. Let's just go to these last two considerations, and then there'll be one little bonus slide, and that's it for today. So 181, consideration 8, concentric polyhedral hierarchy. Thereafter, I set about sorting out the relative numbers and volumes of the most primitive hierarchy of symmetrically structured polyhedral event somethings, all of which are always concentrically congruent, and each and all of which are to be discovered as vertexially defined and structurally coexistent within the pre-time size, pre-frequency modulated isotropic vector matrix. See section figure 98261. So we're going to have a IVM. We've established the IVM that we're working with. That's like our reference frame. And then what's so cool, and this is from grunch.net, from Kirby Earner's work, the shapes are just beautiful. If we take the tet with edge length 1 to be volume 1, it turns out that when you get as tet above, so tet below, you get a cube of volume 3. So this is one of my favorite synergetic memes, which is, if you take a tet first approach, you get cubes. They're bigger than the tet. In fact, they have 3 times the volume. But if you take a tet first approach, you can get cubes cleanly, perfectly. But if you take a cube first approach, you'll never get tets and all that they mean for us who care so much. So go tet first, because you can get more by going tet first rather than go cube first. So you get everything in the cube world as a special case of tet. And this is the volumetric relationships. And here is showing how these shapes map onto identical vertexes, energy events, in the IVM. So Kirby and others are like really exceptionally aware of this stuff, and I'm really learning it. But this is pretty cool to show how the volumetric relationships of all these different shapes, tetrahedron, cuboctahedron, icosahedron, the duo tet cube, that's the tet above, tet below, octahedron. So those are some of those ones here, 1, 2.5, 3, 4, 5. And some that are tantalizingly close to integers, as well as other ones that might be sort of reflecting other interesting patterns like phi or root 2. So just totally cool. Great resource, grunch.net/synergetics. Also known as the cosmic hierarchy. And this is like a lot of sacred geometry shapes. So there's a lot to learn here. 190, consideration 9, Synergetics. 191. This book, Synergetics, volumes 1 and 2, embraces the record of the lifetime search, research, sorting outs, and structural intertransforming experiments based upon the foregoing 8 considerations, all of which I had adopted by 1927. This 1927 inventory has been progressively amplified by subsequent experience-induced consideration. So another classic Buckyism was emergence through emergency, which certainly is relevant now. And 1927 was his emergence through emergency. That was his crisis year. Were these 8 considerations exactly written out in that year? Were they all reflecting the exact continuity of his childhood desire to find nature's coordinate system? For us to wonder. But it's so cool that the 9th consideration ties it back in on itself. And, you got 9, 1 times 9, 2 times 7. A lot of great numerology, of course, all over the place. And it's its own consideration. So those are the 9 considerations that Bucky provides for us when thinking about synergetics, with the 9th one kind of closing the loop and being its own consideration. And again, there's a 10th one about the spheric experience, energetic reality accounting versus abstract cubic accounting, which is something we brought up a little bit, but just it kind of goes off in a few other directions. So just to recap before we go to the bonus slide, vectors are energetic. Lines are not infinite and lifeless. They're terminating and energetic. Vectors describe that better than line segments. They're directional too. Consideration 2, Avogadro's constant energy accounting. This brings in an aspect of finiteness and integer accounting with some invariances and connects volume to geometry and also to some sort of isotropic considerations. The third consideration is angular constancy, which reminds us that edge lengths, vector lengths, are always special case, but angles are generalizable. They're cosmically constant, independent of time and size consideration. The first three considerations lead to the fourth one, the isotropic vector model, or the isotropic vector matrix, which is this special field that's based upon constant angles and constant edge lengths. It turns out that that is one and the same as the close packing of spheres, which is also the free energy minimizing arrangement for atoms, which is why we see face-centered cubic packings. When we think about packings of unit length cannonballs or atoms, like the same kind of atom making a crystal, and we treat the radius as 1, we get the diameter as 2. Unity is plural, and at minimum 2. Diameter. Another way that unity is plural and at minimum 2 is this coexistent relationship between convex and concave. Convex and concave reflect two sides of the same bent coin, and when it's curving in, it's concentrating energy in microcosmically. The outer side is radiating energy out macrocosmically. So unity is plural and at minimum 2 there as well. We then zoomed in on this vector equilibrium as this condition where nature is pulsating through. And there's a VE symbol, and it's related to the jitterbug. And we looked at some of this awesome meta-analytic work, really, by Lattice and Presence. So those are the 8 and 9 considerations. The concentric polyhedral hierarchy also fits perfectly within the IVM in a tet-centric world. Just, what do you get with cubes? You get Minecraft, which is awesome. But then ironically, the computational geometry in the graphics card might even be based upon triangulation. So again, one of the key memes. You go tet first, you get cubes later. You can just have smaller tets. But if you go cubic, you're not going to be able to get all this awesome patterns out afterwards. So consider that. And then Synergetics is its own consideration, like really meta. So here's the last slide. Just some cool images I found while researching in papers and such. So the paper is from 3rd of July, 2020 in Nature Communications, and by Su et al. And they wrote, the title is A Keplerian AG90 Silver 90 Nest of Platonic and Archimedean Polyhedra in Different Symmetry Groups. So like cool research, you know, what we're learning about geometry and the shape of nature and the geometry of thinking is so alive and it's totally contemporary. So just because we might have learned some of the basics when we were young, or some of the basics might have been elucidated a long time ago, it's absolutely an ongoing field of research. Here's a section from the paper. They wrote, although it might be assumed that only cages with compatible symmetry, i.e., e.g., icosahedral within icosahedral, could be nested, so like total, just perfect concentric nesting. For the Zohm tool toy, the mathematician John Conway created a model called Kepler's Cosmos, a model that aligns the 5 Platonic solids, the 2 with icosahedral symmetry, the 2 with octahedral, and the 1 with tetrahedral, #tet. As its name suggests, the inspiration for this model dates back to Johannes Kepler in 1596 AD in his Mysterium Cosmographicum, The Secret of the Universe. Kepler hypothesized that the orbits of the 6 known planets corresponded with 6 spheres, 5 circumscribing the 5 Platonic solids and 1 inscribing the smallest. To test this hypothesis, Kepler became mathematical assistant to Tycho Brahe in 1600 and gained access to more than 30 years of astronomical observations. By 1605, Kepler had shown that the orbit of Mars was an ellipse, culminating in 1619 with his discovery of the three laws of planetary motion, and subsequently Isaac Newton's discovery of the law of universal gravity, love. However, other alignments are possible. Here, we devise an alternative alignment with three different combinations of 4 and 2-fold axes to produce a nest with just 3 different orthogonal 2-fold axes, figure 5, producing a quintuple nest with lower D2 symmetry. Of course, it's also possible to align none of the rotational axes, producing a quintuple nest with trivial C1 symmetry. So the symmetry groups, would love to learn more about it, but it's not totally my expertise. These are just really beautiful images. These are chemical compounds, and it just is really blurring the line between computational geometry, computational chemistry, metaphysics, physics, math, experience. So really nice shapes, really beautiful shapes. That's one figure from the paper. Here's another figure from the paper. This is like, looks like an album cover for some sort of trance album. 555, 333, 3333, 444, 333, 333. All these different symmetries. And then here's some figures that are famously in Kepler's Mysterium. This is really a famous image right here with the nesting. So, this is a 500 plus year trajectory of research. How do shapes nest within each other? Okay, when they do nest, what are their volumetric ratios? Do their vertices align? Are the vertexes of one on the midpoints of the edges of the other, or are they right overlapping? So that's what Kepler was thinking about, and look at the sun in the middle. And then here is an image I found online about that. What's beyond a veil of uncertainty? What's on the other side of the Markov blanket? So we'll just leave it at that. What's beyond the veil of uncertainty? And that's the mystery. Maybe that's the secret of the universe. So today was pretty fun, a little bit longer and maybe different than usual, but we tried to remember, reduce, and reuse today on this special and important day in number 11. So thanks everyone for watching and participating. I always appreciate making these and for the feedback that people provide. So yeah, good luck with your Synergetics journey, and I will see you in 12 and beyond. Bye.